What if everything we thought we knew about the universe was wrong? The Webb telescope has just peered into cosmic dust and found something completely unexpected. This discovery isn't just a new particle. It could rewrite the textbooks on how stars are born and how galaxies move. Prepare to have your mind blown. For decades, we looked to the stars through a veil. Our view, as magnificent as it was limited. Then, humanity launched its greatest eye into the cosmos. The James Webb Space Telescope was not just an upgrade. It was a promise to see the unseen, to look back in time to the very dawn of creation, to witness the birth of the first stars and galaxies in the universe's infancy. Its infrared vision was designed to pierce through the cosmic dust that had shrouded these secrets for 13 billion years. Its capabilities are unparalleled. It can detect the faint heat of a bumblebee on the surface of the moon. It can analyze the atmospheres of planets light years away. It is the most powerful and complex scientific instrument ever deployed by humanity, and it has already delivered on its promise, flooding us with images of a universe more vibrant and more complex than we had ever imagined. But in its primary mission to look back in time, it has stumbled upon something else entirely, something present, something that wasn't supposed to be there. The whisper came from the dark. While studying the chemical composition of a dense cloud of cosmic dust, the very stuff from which new stars and planets are born, Webb detected a faint, unprecedented signal. It was a subtle spike in the energy spectrum, an interaction of light and matter that did not match any known particle or chemical process in our standard model of physics. It wasn't loud. It was a faint, almost imperceptible murmur from the silence. This is the moment that sends shivers down the spine of every physicist. Because in the well-ordered map of our universe, a signal with no known origin is the most exciting thing possible. It is a question mark hanging in the cosmos. Could this be an instrumental error, a known phenomenon masquerading as something new? Or could it be the first whisper from a dimension beyond our own? The scientific community held its breath, and the rigorous work of verification began. But as they dug deeper, the anomaly didn't go away. It only got stranger. To understand the anomaly, we must first understand our map of reality. The standard model of physics is one of humanity's greatest achievements. It describes every known fundamental particle and the forces through which they interact. It is the rulebook for the cosmos. It has been tested and verified to an astonishing degree of accuracy for over 50 years. And according to this rulebook, the signal Webb detected should not exist. Let's get specific. When Webb's instruments analyze the light passing through cosmic dust, they create a spectrum, a chemical barcode that tells us exactly what the dust is made of. The anomaly appeared as an unusual absorption line, meaning something within the dust was consuming a very specific wavelength of infrared light. The energy of this absorption line didn't correspond to any known atom, molecule, or fundamental particle. In layman's terms, the data showed a new particle interacting with light in a way that doesn't fit within our current standard model. Before any scientist can cry discovery, they must first become the ultimate skeptic. The process of verification began immediately and was incredibly rigorous. Was it an instrument artifact? The team cross-referenced the data with Webb's other instruments and with ground-based telescopes. The signal remained. Could it be a rare but known chemical reaction under the extreme cold and vacuum of space? Supercomputer simulations were run, modeling every conceivable interaction. None matched the data. Could it be a distortion from a background object? The team meticulously mapped the area to rule out any contamination from distant quasars or galaxies. After months of painstaking work, every known phenomenon was ruled out. The conclusion, as unsettling as it was exciting, became harder and harder to avoid. What they were seeing was real, it was new, and it originated from within that cloud of cosmic dust. So, if this particle is not from our universe's known rulebook, Where could it come from? This is where we transition from the observable to the theoretical, to the very edge of human understanding. Leading theories like string theory propose that our universe is not all there is. They require the existence of extra dimensions, hidden from our senses, curled up on a scale too small for us to perceive. In this view, our universe is just one brane, a three-dimensional membrane floating in a higher dimensional space. How does this connect to our anomaly? Some models of string theory predict that while most particles are confined to their own brane, some, particularly those related to gravity, might be able to leak or interact across these dimensions. The new particle Webb detected could be our very first evidence of such a leak. It could be a particle whose origin is not in our universe, but in another, parallel universe, just a fraction of a millimeter away from us, in a higher dimension. The cosmic dust isn't creating the particle. It's simply the place where the interaction between our dimension and another is becoming visible. This is, of course, a subject of intense scientific debate. The current consensus is that the existence of other dimensions is a mathematical possibility, but not yet a proven physical reality. But this discovery could be the very thing that shifts the ground under our feet. It could be the first observable, testable piece of evidence that moves the multiverse from the blackboard to the laboratory. Let's pause and consider what this would mean. If this discovery is confirmed, it's not just another entry in the particle zoo. It's a fundamental shift in our understanding of reality. It would mean that the space we inhabit, the time we experience, are not the complete picture. It would imply that our universe is just one thread in a grand, multidimensional tapestry. It would raise philosophical and existential questions that would dwarf everything that has come before. Are these other universes like our own? Do they have different laws of physics? Do they harbor life? The discovery has already ignited a new fire in the world of astrophysics. Future research avenues are exploding. Scientists will now look for this same anomalous signature in other cosmic dust clouds. They will design new experiments, perhaps even new space missions, specifically to investigate these potential dimensional gateways. We are at the dawn of a new era of cosmic exploration, where our goal is not just to map our own universe, but to find the boundaries of it, and perhaps what lies beyond. The profound significance of this potential discovery cannot be overstated. It emphasizes just how much we still have to learn. For all our progress, we have been studying a single page, believing it was the entire book. This new particle could be the first word from the next page. It has the power to transform our perspective, showing us that our universe is just one thread in an infinite interwoven tapestry of existence. We are on the cusp of an awakening, a realization that could be the most important in human history. This brings us to a final thought. This is a story that is still unfolding, and we invite you to be a part of the conversation. What do you think this discovery means? Share your thoughts, your speculations in the comments below. Stay tuned for updates as scientists race to confirm and understand this anomaly. We end with a powerful thought. Are we on the cusp of an awakening, realizing our universe is just one thread in an infinite tapestry? The great silence may be about to be broken, not by a voice from the stars, but by a whisper from another world, carried on a mote of cosmic dust. Thank you for watching.